81 operation, I think. It's only 8 of them. I need one more. Maybe we could be a little bit more efficient than 81 multiplications if we, I could pair them up, and I could write that each one of those pairs is x squared plus 2x plus 1, and then I could multiply those out. But obviously that's going to take some time. However, what you probably have realized is that I can write down 2 of the terms straight away, because the first term, as it's written, will just be x times x, will just be x to the 9. X times itself 9 times. And similarly, the last term will be 1 times itself, so it'll just be 1. The terms in the middle are a bit more complicated. So, how do we do them? Well, the next term is obviously going to be some number of x to the 8s. The question is how many? Followed by some number of x to the 7s. But how many? Followed by some number of x to the 6s. But how many? And so on. Well, how do we get x to the 8? How do we get the x to the 8th term? Well, there are several ways to get it. I could do this x here, this x here, this x here, this x, this one, this one, this one, this one, and the 1. That would give me 1x to the 8. Or I could do 3, 4, 5, 6, 7, that one, and another x. Or I could do these 2, that one, and the remainder of the x's. What I'm doing, essentially, is saying from those 9 brackets, I need to choose 8 x's. From those 9 brackets, I need to choose 8 x's. That should sound very familiar. From the 9 brackets, I'm going to choose 8. And if we work out what that is, 9 choose 8, there's 9 ways to do it, because I can pick this one, or this one, or this one, and so on. So there are 9 ways to choose the 1, there are 9 ways to choose the x's. And that's 9. And it's the same idea for the 7s. If I'm doing x to the 7, how many ways are there to pick that? Well, the question is really, out of my 9 brackets, I need to choose 7 x's. And 2 1s. So if I choose 7 x's, that's going to be 9 choose 7. Which is, what, 36. And so on. I'm going to introduce a slightly different piece of notation here. Instead of 9 choose 8 written like that, we usually write them, and this notation could be a little bit confusing, as 9 choose 8. So it's not a vector, it's not a fraction. So it's important that when you see these, you're thinking about the context. But it's a different way of writing our choose function. And this one is 9 choose 7. And it's just a little bit more compact. So that means if we're doing x plus 1 to the 9, I can write the whole thing out. It's going to be x to the 9 plus 9 choose 1, x to the 8, plus 9 choose 2, x to the 7. Nope, let's not write it like that. That's probably going to confuse you. Let's do it the other way around. X to the 9 plus 9 choose 8, x to the 8 plus 9, choose 7, x to the 7. 9, choose 6, x to the 6. So on. 9, choose 5, x to the 5. 9, choose 4, x to the 4, and so on. Nine choose 0. How many ways are there to choose 0 from 9 things? There's only one. And why was there a bit of confusion a moment ago? There's a bit of confusion a moment ago because 9 choose 8 and 9 choose 1 are the same number. Because if you're choosing 8 things, it's the same as leaving 1 behind. Choosing 1 to leave behind. So 9 choose 8 is the same as 9 choose 1. Similarly, 9 choose 7 and 9 choose 2 are the same thing. If you're choosing 7, you're choosing 2 to leave behind. If you're choosing 2, you're choosing 7 to leave behind. It's symmetrical. Pattern continues. 9 choose 6 and 9 choose 3 will be the same. Let's pick a colour. Yellow. And these two will be the same. So that's the binomial theorem. I'm going to write it out formally. Which is x plus n. Sorry, I'm not going to write x plus n. I'm going to write it the same as it's in the IB formula booklet. A plus b to the n is equal to, now before we did x and 1, so the 1 didn't appear because when you multiply by 1, you just get 1 every time. But we were still multiplying by 1. So there'll be a's and b's in this expression. This expression becomes a to the n. And obviously it finishes with b to the n. B to the n. The last term. And it's just about getting the ones in between, and they follow these binomial coefficients. Another name for our choose function is the binomial coefficients, because it's binomial expansion. I didn't say why it was called binomial, but it's called binomial. Binomial just means two names. Two names in this case are A and B. Before, they were x and 1. So this works as long as you've got two terms in the brackets. So we've got a to the n plus n choose 1. So before that was 9. So n choose 1, whatever the power is. A to the n minus 1. So this was 9 originally, and then it went down to 8. It's the same thing, but this time what we didn't have before is we were also, those 8 x's were being multiplied, and then they were being multiplied by 1. So we didn't have that 1 originally, but it's been replaced by a b. That's going to be in there. The next term will be n choose 2, a to the n minus 2, b squared, until you get to there. So that's the binomial theorem, and it can make expanding out brackets really quick. So let's say I wanted to do x plus 5 to the 6. These numbers are going to be big. The last number, 5 to the power 6, is going to be very big. So if we write that out in full, it's going to be x to the 6 plus 6 choose 1, x to the 5 times 5 plus 6 choose 2, x to the 4 and 5 squared plus 6 choose 3, x cubed times 5 cubed plus 6, choose 4, x to the 4 times 5 to the 4 plus 6, choose 5. Oh, sorry, that's not quite right, is it? X squared, it should be. X squared. So these numbers should be checking always add up to 6, 5 and 1. There. Or 4 and 2 here. Sorry about that. So x to the 3, 5 to the 3, x squared, 5 to the 4, x to the 1, 5 to the 5, plus x to the 0, 5 to the 6. And obviously you'll need your calculator to do that. You're not expected to do these by hand. So we get x to the 6 plus 30 x to the 5. 6, choose 2. 30x to the 5 plus 375 x to the 4 plus 2,500. These are just coming off the calculator, typing in the choose function. X squared plus 1,870. I feel like I've missed one out there. Right, that's right. Okay, x to the 6, 30x to the 5, 375x to the 4, 2,500x cubed, 9,375x squared, 18,750. Okay, the clever thing about this, the nice thing about this, obviously it's fast if you've got a calculator, but it's also got a sort of a use. Let's say that I wanted to evaluate 5.01. Just to keep it easy. 5.01 to the power of 6. So I'm going to use my result from before. And I wanted to be able to do it quickly, and my accuracy was important, but maybe I didn't need to be super accurate. Obviously, these days, we'd be able to do that with a calculator, but I can quickly check. Now that I've got my expansion here, I can quickly check what that would be by hand. Because what this essentially is this is 5 plus 0.01 to the 6. These two things are the same. But this is 5. If I call that 5 plus x to the 6, then that's the thing that I've just expanded here. Where x is really small. Now, the thing about x being really small is, okay, x is really small, but x squared is 100 times smaller than x. And x cubed is 100 times smaller again, which means it's 10,000 times smaller than x. So these numbers, this one, is going to be absolutely tiny if x is 0.01. And this one's going to be really small as well. In fact, I could probably, if I wanted to know the value of 5.01, I could probably ignore all of those and just use those three terms and get a pretty good estimate of 5.01 to the 6. I'm going to estimate that 5.01 to the 6 is the same as 15,625 plus 1,850 times 0.01, which is my x. I'm working this way. Plus 9,375 times 0.0001. And that number itself, you can already see that number itself is going to be really small. So it's approximately equal to 15,625 plus 187.5 plus 0.9375. If we do that addition, 15625 plus 187.5 plus 0.9375, then you get 15,830.44. I'm just going to round that to the nearest whole number. And I'm going to leave you a little exercise to have a go at. So I'd like you to use the binomial theorem. A plus b to the n is equal to a to the n plus n choose 1 to the n minus 1, b to the 1, n choose 2, b to the n minus 2, just b squared. Excuse me. So n choose 3, a to the n minus 3, b cubed, plus all the way till you get to b to m. To expand out in full, let's go with 2 plus x to the 5. So there'll be 6 terms. You'll need your calculator. What does that equal? It should start with 32. 2 to the 5. 2, 4, 8, 16, 32. And it'll end next to the 5. And then once you've done that, I'd like you to estimate 2.01 to the 5 to an appropriate degree of accuracy. Best of luck. See you tomorrow.